And we had many different methods to solving them. So we had graph, elimination, substitution, and Gaussian. So we had the 4 different methods for solving the degree 2 systems where 2 lines meet. So what we're going to look at today is 1 quadratic and 1 linear. Now this problem is a little bit different. So for example, it doesn't always have 2 answers. You could have situations like this. 1 quadratic, 1 linear. 1 quadratic and 1 linear like this. And then 1 quadratic and 1 linear like this. So you could actually have 2, 1 or 0 solutions. Yeah. Let's have a look at how we solve these problems. So if I can just borrow the book for a second, I'll just get a question there. Thank you. So here's our first example. Y equals x minus 1 and y equals x squared minus 4x minus 1. Okay, so for this lesson, I don't have too much to show you. I just wanted to show you how to solve these with a couple of examples. So we can't use any method here. In fact, only one method is suitable. We can't use elimination. It's impossible to eliminate the x's at once. I guess we could kind of eliminate the y, but the best method here is substitution. That is, the y, which equals x minus 1, replaces this y here. So instead you have x minus 1 equals x squared minus 4x minus 1. Now this problem has become a lot easier, because now it's just a quadratic, because we have now x squared minus 5x. No number at the end. Yeah? So that's equal to x minus 5 equals 0. So we have 2 answers, 0 or 5. And then we'll get the 2 y values. If I put 0 in here, minus 1 or 4. So very quickly the graph looks like this. Here and, well, maybe more, something like that. Yeah, so these are the 2 points here where they meet. So really, it's just like solving quadratics, except they can be a good bit harder. So once you write this down, we'll do a hard example now. Got that? Yeah? Can I scroll down to another example? Yeah? Okay. 2x squared minus 11x plus 54 equals 0. 4x squared plus xy minus 5y squared equals 0. Now, you can see straight away this is much harder, because Did I write that down? Oh, sorry, a small mistake here. I meant to write... What the heck? Sorry. I skipped lunch, and this is the problem. I should never skip lunch. And Bruce doesn't have any cookies for me as well. It's absolutely a disgrace. Okay. These are our two equations here. So as you can see, this is harder than the last one because both equations have x and y in a sort of complicated way. But the idea is still the same. Yeah? We still need to find y from the first one and put it into the second one. So I'll take this one, and do we remember what you say when you have y on one side? Yeah, make y the subject. So, what do I get here for y? I get, let's see, 2x plus 54 equals 11y. So if I divide by 11, I get this for y. Yeah? Mm-hmm. Then I need to put this in here. So now I have 4x squared plus xy minus 5y squared. Now, I have to expand. Can I scroll down a little bit? Okay. Alright, so expanding now. That's 4x squared plus 2x squared plus 54x over 11 minus 5, and that's all over 121, 4x squared plus 216x. $50 times 50 is 2,000, but no. Somebody with a calculator? Don't make me do this now, come on. Thanks. It's much quicker. 916. 2916. Okay. Yeah, 29. Sorry, yeah. Okay, what to do next to try and simplify this a bit more? What should I do next? Yeah. By what? Maybe not 11. 121. So if I multiply everything by 121, I get 484 plus 22x squared plus 540 and 594. Okay, 594x minus 20x squared minus 1080x plus something quite large at the end. 14,580. Thank you. Is that okay? Yeah. So how many x squareds do I got? I got 486 x squareds. Yes. How many x's do I have? Is it minus 486 x? Is it? Help the teacher out here. Is it? Plus 14,580. All of these numbers can be divided by 486. That's x squared, that's x, and oh my goodness, that's 30? Okay. So that's x minus 6, x plus 5. So x equals minus 5 or 6. Now we have to get the y, so if we go back up to here, putting in the x, that's 4. Yes. Yes, thank you. So this is it's plus 30. So it has to be not 6 and 5 then.
No.
So I made a sign mistake somewhere. Where's my sign mistake? Minus 5 part? No. Oh yeah, of course. This is a minus here. Minus. It's okay now. So it's still right. Okay. And then if I put 6 in 12, 7, is it? 12 plus 54 is, no, 6. 12 plus 54 is 66. 66 divided by 11 is 6. Well, I'll just check here actually. Minus 5 and 4 and 6 and 6. Correct. I told you it was a hard one. But it's only hard because the numbers are big and long. It's still the same idea. You put the y in here and you simplify. And it'll be easier for you because you'll have calculators. Yeah. Okay. Let's see. There is another way to do these questions. So I'll do this one again, but show you the other way to do it. And you can't use this method for the previous example. So let's have a look here. We have 2x minus 11y plus 54 equals 0. And 4x squared plus xy minus 5y squared equals 0. And the trick here is we have to factorize this quadratic. It'll be an x plus y, and it'll be an x minus y. So we need two numbers that multiply to make 5, two numbers that multiply to make 4, and the inner and the outer has to make 1 here. So 5 and 4 actually sound good. If I put a 5 here, I'll get the minus 5y squared at the back. If I put a 4 here, I'll get the 4x squared in the front. No, that won't work. Maybe I have to put the 4 here. So that'll give me minus 5. Yeah, this will be it. So y by minus 5y, minus 5y squared. X by 4x, 4x squared. This is 4xy minus 5xy. The sign's the wrong way. No problem. So this one here is the minus and this one here is the plus. Let's check again. Minus 4xy plus 5xy makes that. Okay. Equals 0. So now what you do? Well, we have two equations, number 1 and number 2 here. So if we look at the second equation, the only way this can be equal to 0 is if x minus y equals 0 or 4x plus 5y equals 0, and we still need 2x minus 11y equals minus 54, and we still need 2x minus 11y equals minus 54. So what I've done is I've changed it into two simpler problems. So let's have a look at each one here and see if we get the same answers. What will I do here? I'll multiply this by 2, and then I subtract. So minus 2y minus minus 11y is 9y equals 54. That means y equals 6. I put that back in, and I'll get x equals 6. I'll multiply this one by 2 as well. So that becomes a 4, a 22, and 108. 4x minus 4x is gone. 5y minus 22y is 27y. 0 minus 108 is 108. So that means y equals, not 4, 4. 84. If I put that back in here, y is 420 divided by 5 then, yeah, minus 5, yeah? So I have minus 5, 4, and 6, 6, which, where's it gone? The same answer. So it's a different way. It works if you can factorize. Now you see, this is what I mean by factorizing. You can't really factorize this on the calculator, and you can't really use the minus b formula. So this is why we were practicing factorizing a couple of weeks ago, because it actually is useful here for this one to simplify. So there's our two answers then. Okay, so write this one down. This is the other method you can use. Got that? Okay. Do we all write that down? No, not yet. Okay, that should be enough time for everybody then. So let's just talk a little bit about the graphs. So in the exam, they sometimes ask you to sketch, and it's not so difficult if you have 2 points, because if you have 2 points, you know that both the line and the quadratic go through the 2 points. But you don't have to sketch these ones in the exams, because these quadratics, they don't look like this because they have the y squared in it. I wonder if anybody has seen these quadratics before. Anybody seen these types before that have a y squared and an x squared? No? Yes, maybe? If you've seen them, what shape do you think it is? Go for it. What shape do you think? Yeah, what's the shape called? You can get these shapes from equations like this, but this is not part of this course, so you shouldn't be asked to draw this. But if you're wondering why there's two answers, is because the line will cut it twice like this. But this is not part of the course. It's just so you know, in the exam they shouldn't really ask you to draw this, only the previous example. Okay? Now let's see, I think I'll let you try these, and we won't give you too many, we'll say 2 from each. So 1 F1G, 2 F2G. I said 2 from each, so there's 4. Now let me get the attendance. Okay, I'm just checking the attendance here. Alvin, yes. Amelia, Tony.
Yeah.
Tony, I'm so hungry and tired. Don't make me say it twice, please. Clement. Yeah. Jonathan. Donna. Dylan. Drew. Hanukkah. Yash. Eric.
Yeah.
Where?
Yeah.
There. Andy. Dennis.
Yeah.
Sarah.
Yeah.
Fahad.
Yeah.
And then the engineers. Engineering and science now. Andrew, Bruce, of course. Monica, Chrissy, Jerry, KJ, Brian. That's his new name, FYI. That's Brian right there. Put your hand up, Brian. That's Brian. Oh. What's he want? Nothing. Good. Okay. Where was I? Yeah. Lee. Victoria. Sean. And Sammy. Oh my goodness. So I got everybody. How wonderful for me. Okay, let me just check how we're all doing. So how are these going? Easy peasy? Yeah? And how are these going for you? Easy? Okay, how's it going here? I'll just make it roughly right.
Negative 5 is like here.
Oh.
Can the shape be like this?
It cannot. Where are your 2 points?
Negative 1, 4, here.
It's only 1 point you see. So your quadratic has just this 1 point at minus 1, 4, which is here, like you said. And the line passes through this one. And what's the quadratic intercept?
Negative 9.
Negative. Yeah, that's fine. And the line is here. So if the line intercepts negative 9, it's underneath it. How are these going to you, Jay? Good stuff. How are these going for you? They're going okay? And you guys are working on these, yeah? Okay. They're all okay?
Yeah. These are okay?
No problems? And Christy, they're all okay? No problems? Okay, you start working on these, yeah? These are quite tough, aren't they? That method is a bit easier, alright, yeah. Which one are you doing? And you have trouble or no trouble? Trouble. What no axis you want? Or minus 2? You get this? You seem confused. So you got this. No, this is plus 1. Because, yeah, this equals 0. So this is 1. So change this to plus 1. Or, yeah, minus 2. Yeah, and then 1 in here gives you y. And then minus 2 in here gives you the other y. Yeah? Okay. Yeah, I know, this last one's hard. Yeah, why? Tell me. I'll talk about this in the next class, but I want you to think about the reason why. Yeah. I'm going to take some of these from hungry. How much have you eaten today? How much have you eaten today with this? Was this small at the start today? Wow. Good for you. Keep going. Give me finish. Yes. What about it? Huh? make minus 2. So blank multiply blank equals minus 2. And they must add to make 1. So I could go with 2 and minus
随便组织我的泡面料的
Yeah? How are you going, Bruce? Are you okay? You're okay, good here. Okay, Jerry, how are these going? Photograph? A diagram? And Ron, how are you going? Are you only starting? You're studying. And morning check. Believe. Why do you think it's wrong? Oh, okay. You need two numbers that multiply to make 4 and add to make 8. So for example, wait, I don't think this is possible. Is it 4? Is it 8? No, you can't use it. So maybe this is wrong. Okay, let's see. Yes. Yes. What did you make? You forgot your 4 here. No. That's the mistake. Okay. So yeah, divide 4. Yes, Mike. For which question? Maybe 96. Is it possible to 96? 14 squared is 196, yeah. How do you remove it? Multiply by 196. Yep. Okay, how are we doing up here now? No. It's nice, but I think you drew this a little bit off. So you see, because this is minus 5, there should be like down here at minus 5. So maybe it's more like this. Yeah. Is that your one for the first one? That's even more different. Oh yeah. No, you see, wait, look. It can't be this, because if it was this, then you should have 2 answers. So it can't be that.